Okay, you are live.
Thank you everyone for joining us today in our Hyperledger Telecom SIG bi-weekly calls. And this is what we started in Hyperledger Telecom SIG is to invite speakers. And because in Telecom SIG we started this project called Telecom Decentralized Identity Network, and Dinkar was a mentee in this project, and that's what we finished. This I think this is Linux Foundation. Every year, Hyperledger start this project, and under this, we started this project called as Telecom Decentralized Identity Network. And okay, so before I start, I want to introduce about more on identity. So in early 2000, we can see that for everything we need different ID. For example, for driving license, we need different ID, and for particular use cases, we need different IDs at every different point. So, but the problem with this is, first of all, this is centralized, and we don't have any security and privacy, and no user experience was there because we have to carry multiple identities at particular time. So in 2010s, what happened is we have in computer systems we have a concept called single sign-on, and where we can log in through, let's say, Google. We can through Google account we can log in YouTube, Google Drive. So the single sign-on was there, and this is called federated identity. There was a user experience, and this is helpful, but there was an issue in security as well as privacy. But nowadays, of course, we are in Web3, and how to protect ourselves in Web3 world, and how we can ease the life of a user by using a self-sovereign identity, in which we can preserve the security, privacy, and user experience as well. So this is a little bit introduction about identities and uh, and what is the advantage of having one ID kind of concept is it's easy to access, and there's no more ID and password concept. And then uh, we have enhanced privacy, and there's no fraud that means compared to once we have multiple ID systems in which we have to log in via different accounts, and we have to remember different IDs and password, and that's a problem in this ecosystem. And before I start, I want to also discuss about what is verification so that we can understand DID better. So, for example, if there's a car sharing service, so we this mobile driver license, you can through this you can check verify this car status, reservation, and other services regarding this car sharing. And then same way, age verification or something like this through identities, these things can be possible. This is called as verification, and this all these concepts we are using in self-sovereign identities. And in SSI, we have a concept in which we have three entities. One is issuer, holder, and verifier. Issuer issues these kind of, let's say, take the example of degree, and issuer issues these degrees to the holder, and then holder has to present this to the verifier, and then verifier verify through issuer or verifiable data registry. So in this case, we preserve security, preserve the privacy of this user, which is a holder in this use case. So SSI are decentralized digital identities where verification by a third party, we don't require contacting the issuer all the time. Also, this is so we need two things: decentralized identifiers and verifiable credentials. And in our project, which is TDIDN, we are using Hyperledger Indy and Hyperledger Arrays for implementing this whole SSI ecosystem. So in our case as well, we are using this issuer holder verifier concept. Holder is like holding these identities in our case, and the structure is that's what we are using SSI. And this decentralized identities is a number kind of thing where you can see there's a scheme There's a DID method, DID method specific identifier, and this is unique identifiers. For example, each user is assigned a unique DID as per the W3C DID specification. So we have to follow some standardizations so that every DID means anyone can use this DID as in the global environments as well. So in our case, we are using this W3C DID specifications, and then we have a blockchain storage, which in which we are storing DID and user public keys. And this is, of course, it can be a permission blockchain, depending on the needs. And of course, compatibility is very, very important, that we can design for use across various distributed ledgers and network. So for example, we can use it as a public permission blockchain. We can use it as a whole private blockchain, depending on our use cases. So that's a good approach. That in our project also we are using Ethereum, so people can use Ethereum or other testnets to test this ecosystem. And again, before I start, these are like introduction terms that we use in DID. That's called verifiable credentials. So this verifiable credential contains claims, and this is like a digital this is tamper-proof, as well as we can enhance the privacy. And this verifiable credential contain claims, and then we have multiple credential possible by which like holder can hold from the issuer. And this is like a service digital certificate that verifies a holder claims about their qualifications, attributes, or rights, whatever we want. But sometimes what we need is selective information from this credential, because we can have multiple claims in this credential. So, and this we call as a selective disclosure, because in the hash, because we are using these, we are storing these claims in terms of hashes. And you can see this claim 1 plus salt, that's what we're adding, and put it a hash over it. And then in the last stage, we are signing all these things so that we can send the credentials to the holder, and then holder can use this for the verification purposes as well. And this is again a very important concept, because sometimes we don't want to send whole credential. Instead of that, we from this whole credential, I just want to send a particular claim. In that case, we call this as a selective disclosure. So coming to telcos, about this decentralized identity ecosystem. So we can use telcos at different levels, as an issuer, or either as a holder, or as a verifier as well. So as you can see, as in the issuer side, these are the use cases that are published by various bodies, standard bodies as well. GSMA and other consortiums publish these kind of papers in which they mention that how telcos can leverage this idea of decentralized identities. So because telcos are regulated to know their customers, right? So that's what telcos can issue this verified KYC informations as well, which includes personal identification, or proof of credential, or premium customer credit score, location, a lot of things, right? So because although telco has all these details about the holders, so for holders, telcos can help customers manage their identity information in a mobile wallet, because anyhow, in terms of SIM, we get some kind of keys, right? So that's what we can store with this. Holder can store same way in terms of mobile wallets. This can be like a custodian service where key plus credential can be with holder. And for verifiers, telcos can support verification through APIs offering for service provider. And this is where the idea of TDIDN comes, because how we can use this concept of verification, because OTP. So generally we use OTP, right, with telcos, and this generally we use for the authentication. That with this particular OTP, for example, if let's say I'm buying something and someone wants to verify something, then we send this OTP to the issuer, and then to the holder, and then holder said, okay, this is the OTP. and then verification is possible. So this is very, very important. And this is how we started this TDDIN concept, in which there can be a multiple telecom network can come, and we, for the starting point of view, because this is we started this so that we can engage multiple telecom operators, and then they can give us feedback as well, and then we will improve. So initially we started with 3 blockchain networks, which is IMEI, CDRs, and DIDs, and there are multiple smart contracts, and also multiple authorities. It can be like a authority can be like, for example, IMEI. So generally, the SIM is issued by these telecom operators, right? But again, authorities can control a lot of things. For example, we have Central Equipment Identity Registries, which is CEIR, that is managed by the governments to check whether this IMEI is valid or not, right? So that no one can use stolen phones and kind of concept. So same way, multiple telecom operators can join this network, and in this network we have main components. 3 main components is one is sovereign identities and decentralized ledgers with different public blockchain networks as well, and then smart contracts. So as you can see in the architecture point of view, as a customer, so we need authorized authorities through which we can register this on IMEI stuff, because IMEI is very, very important as a base for this. And take the reference as a customer as a midpoint, and where we need blockchain DIDs. First step is to get these DIDs from the blockchain DID network, and then we can use these DIDs to the third party. For example, again, instead of sending OTP or your information to the third party, what we can send is we can send DIDs. So this is the use cases on top you can see in respect to the customer, but also at the same time, telecom operators can also utilize these DID networks, for example, for CDRs and for SLAs and a lot of things, right? So as you can see in the architecture, customer is also getting benefit, telecom operator also getting benefit, and then same way, if government has this CEIR concept in the country, so they can also utilize this DID network based on that mapping of IMEI on these networks. So as you can see in this architecture, and even Dinkar is also here with me, and we will show you that how what the plan is, and then how we can expand this concept on multiple use cases in the telecom domains. So, and how TDIDN solve these problems by replacing OTPs and usernames with these DIDs to streamline authentication and improve user experience. And of course, there's a lot of spams going on regarding these OTPs and stuff. And also by leveraging this blockchain to link this IMEI number and ownership and status with these user DIDs. So what happened is generally we are maintaining telecom registries and boosting so the problem is this, that if like every operator or everyone is storing such kind of registry, so there's the issue of interoperability all the time. So that's what, to boost the transparency, this can be very helpful for customer as well as for the telecom operator. So TDDN also allows for selective disclosure, which is, I already explained that, letting customers share only necessary identity details for this particular transaction. This will increase the privacy and minimize the data breaches. That's all the means for ordering pizza, for any small thing. Now people start taking your identities, and then they extract a lot of information out of it. Instead of this, if we can send this directly, a particular information out of that claims, I mean, so from this credential, a particular claim can be sent as well at particular point of time, and that's what selective disclosure is. And not only customer point of view, but it also includes TDDIN also includes this telecom operator advantages as well, which contains because this network also stores CDRs on blockchain tied to user DIDs. In that case, this is really helpful for smart contracts to run, and then automatically this SLA terms should be matched, and this will enhance the security and efficiency in the whole ecosystem. So depend on the consortium. So these telecom operators can join, and then they can solve all these things. So you can also download this repo and documentation from this TDIDN Hyperledger Labs, and also we have solution brief on this, which I will show you after this demo. So I think I request Dinkar to share his screen and show us a demo.
Yeah, sure. Yeah, so before just jumping to a demo, I would like to explain a little bit about more into the architecture. So basically, in the current implementation, we have these three different blockchains for different purposes. And so the blockchain for DIDs are just used for storing all of the data as well as the public key. Nothing personal information regarding the customer is not stored there. It is just for that the verifiers can just get the public keys and just use them to verify the users. And for this, we are using Hyperledger Indy as the base ledger. And then we have this blockchain for serials and blockchain for IMIs. So particularly the blockchain for IMIs, in that we just store the IMI along with the status of the customer device. So basically, let's say the, the customer device got stolen and they want to report it to the authorities so that no one can on the network can use the device anymore. So they need to uh, notify the authorities, and the authorities need to update their databases so that it does not allow the customer's device to be operated on the network particularly. So right now, GSM just has a centralized database, and all of the other authorities just need to have a copy of the database and then also update it accordingly. So this is kind of like a time-consuming process and also very like costly. So in here we just have like this decentralized blockchain. So this is a Ethereum public testnet, and we just use it for testing purposes. But basically, we have a smart contract on the testnet, and it just takes care of everything regarding how the IMAs will be stored along with the dates and the status, how the status of the IMAs can be updated, because we cannot just allow anyone to update the status of the IMAs. It needs to be through authorized authorities, and then also authorized authorities need to be able to verify that the owner of the device, which they are claiming to be, are the right owners. And then we have this third blockchain for serials. It's very basically the same how it's for blockchain for IMIs. We are also like, so the thing is, we have not deployed it on the Ethereum's testnet, but we already have the smart contracts ready for that. And yeah, the thing is, basically, let's say you are making an international calls or even using some third-party telecom operators hardware, which is not related to your telecom operator, then you have then these telecom operators have this settlement because they are using each other's hardware. And in this case, CDRs are generated. But the problem is that there are always third parties which are involved in settling these CDRs, and it's like a very long and costly process again. So now these two telecom operators, let's say for example, can have a smart contract which is deployed privately but on a public blockchain. So only these two telecom operators using their DIDs can access that particular smart contract, even for writing or just for viewing purposes. And it's on the public blockchain. So the benefit is that anyone in the ecosystem can just look at the code and verify that it's like a legitimate smart contract which these guys are following, and also can take as an example for that. And then there's always these sorry SLAs, so service level agreements. So it's like very difficult to manually keep track of um, every policy which they have implemented. But if we can do it automatically, it's like very easy, and it also have like this feature of transparency. So that's very good, right? And yeah, for both of these, we are using these public Ethereum testnet. And yeah, and most of the focus is regarding the customer in architecture. So we want that the customers just have like a very easy way to navigate through and just can get everything done. So as Vipin sir already mentioned, if the customer wants to create a new account with a third party, they don't need the SSO anymore. They just need to give their DID and just prove that they are the owner of the DID, and the third party can just allow them into their ecosystem. Also, this another use case is, let's say there's a third party which wants to know that if you hold a phone number of a particular telecom operator, they don't need to know the exact phone number. They just need to know if you hold the SIM card of, like, let's say Vodafone or Jio, which is like very popular in India. So you can just prove this part without revealing your phone number. And this is where the selective disclosures are being used at this point. And it's like it's a very great thing because now I don't need to specify my phone number, because the problem is that, let's say, the third party database got hacked. Now all of the details regarding mine, all of the information regarding me is like now breached. And also these third parties also sell our data. So that's like not the very safest option. So, but yeah, in this case, we just need to just transfer our TDIDs, or in some case, we can just transfer these verifiable credentials without actually revealing our actual data. And yeah, I think for the most use cases we have this. Also, now in this case, what we have assumed is, let's say, whenever you go to a telecom operator, instead of just giving you a SIM card, they will also give you a verifiable credential, which you can store in your wallet, so that you can just show these credentials to the third party. Like again, for verifying if you own the SIM card of that particular telecom operator, instead of just telling your exact phone number and getting spam calls. Yeah. And yeah, so basically this is for the architecture part, and for the implementation. Okay, let me see. Yeah. Now, how this thing? Yes, sorry. So in here we have like two different um applications, we can say. So first is, let's say, a third party provider. In this case, this can be the third party provider, and then we have our own user wallet. So in the future, it is going to be more hardware specific. So let's say once you have your own device, you can install the wallet on that device. You can store all of the dates, public keys, all of the credential on your device itself. You don't need to have like this web-based approach. But for right now, for the demo purposes, we have this, and here the users can just come in, create an account, just give your name, email, or password, just create something, and you can just have that, and you can just log into your account simply. Yeah, and so you can see your web wallet UI. And here I already have a credential issued to my wallet. So this is the one which I was mentioning. So it specifies that the operator is the Vodafone, and my phone number is some random number. But I can just prove that I own this credential, and it has been issued to me by Vodafone, instead of just revealing this phone number and protecting me from all of this stuff. And this here, let's say you want to create an account on this application. Now you can just use this connect wallet feature, and it will automatically go to your wallet, get your trade, verify the trade using the public keys on the blockchain, and then yeah, it will just allow you into the ecosystem completely. The next step, yeah, okay, so this is kind of like the POC which we built for different use cases. So this is the first one. So it says request SIM card. So if I click this button, what it does is it automatically issues a credential for me. So we are assuming that when you go to a SIM provider, they will also ask for your DID, and then can issue this credential with your phone number to your wallet itself, just by providing your DID, right? And then in here we have this request device thing. So what it does is it basically gets you an IMI number attached to your DID, along with your status on the blockchain registry. The problem actually right now is that we are using the Ethereum testnet, and the fees is very high at the moment, and I don't have that much amount of Ethereum in my MetaMask wallet. So I have this 0.0885. I can try it if I request IMI. No, it says failed. Okay, also, Can you see my terminal right now, or is it just the screen?
It's just a screen. So
Okay, let me just reshare it.
but the code is already available, so anyone can test with enough amount of test net test tokens, whether it's a Polia or something. So anyone can
Yeah.
test it from Hyperledger Labs. Code is already.
Can you see it now?
No, we can't see it. You have to share whole screen. I think that's.
Yeah, the thing is, I can't
You
get
can,
back to Zoom sharing.
yeah, you can just stop and then you can reshare. That's it.
Entire screen. I think it should be visible now.
Yeah, now it's visible. Yeah.
Nice. Sorry for that. Yeah. But yeah, did I lose it? Yeah. So here it is mentioning that I have just insufficient funds for the gas price and the value to just go to the Ethereum testnet and just publish this transaction. But I already have submitted a DID. Like I already have an IMN number which I used for this earlier purpose, and I can just test everything with this. So once you click this request IMN number, you get this type of thing where it mentions that this is the DID you own, and this is the IMO number which has been allotted to you and stored on the blockchain level, and the status of the device is currently whitelisted. So now, if I want to just check the status of any device in the world, I can just come here, click this, and just enter the IMI number, and yeah, it says whitelisted here, right? And the thing is, the the blockchain which we are using is like it's okay. So the smart contract which we are using is like permission and like public too. So basically, what does that mean is anyone in the world can see the status of these devices, but not everyone can just write to this because it has to be these authorized authorities, let's say the telecom operators or the GSM and stuff like that. So let's say I want to update the status of my device. Let's say my device got stolen and I want to update the status. I can just enter the IMI number and I can select the status from whitelist to blacklist and I submit it. And it says you are not authorized to do this. The reason for this is because this is not the DID which owns this IMI number. So I need to create an IMI number on the blockchain registry with this
So
data and then
I want to add one important point. So, for example, in CEIR, all right, Equipment Identity Registry. So, generally, like this portal will ask you like, tell me your details, for example, IDs and different things, and then they match, and then they will say, okay, you are the owner of this particular mobile, let's say, and then they only blacklist this IMEI or device. So in this case, it's not needed because that's what how this is because it's already connected to DID, and that's what you have to prove that yes, you are the owner of this DID. And I think in that case, you can I mean, means instead of going through this whole process manually, you can directly call through DIDs. Yeah, then go ahead.
yeah.
Is the DID associated with the account or is it associated with the like mobile device? Because sorry, go ahead.
Yeah, sorry. Yeah, so basically the data is associated with the um, mobile device, the IMI number, which we have. So let's say, for example, you have three devices and so you can have these three different registrations on the blockchain level, which says that this one date is specified to these three different devices. And then yeah, you can maintain this status differently using just one date.
So then your DID is also associated with like suppose, for example, this laptop, and that's allowing you to be able to say, hey, my phone was stolen. Please like help.
Sorry, I was not able to hear you very, like, can you
All
repeat the
good.
question?
Sorry, continue.
Okay, yeah, nice. Yeah, and yeah, regarding the SIM card, I think I already told that we have done the request device, which is the image basically. You get something like this, and yeah, yeah, update device status we can't because we are not authorized to do that. Okay, so there's also this verify operator. So this is the use case which I was talking about, where you don't need to specify the exact number you own, but you can just verify that if you own a number by Vodafone operator, and if I just click this, it just goes to my wallet again. Request for the credential, do a bunch of calculations, and just tell that if it is if I have the number with the Vodafone operator, and it says verified. So if I don't have the credential, it will just say I'm not verified or stuff like that. But yeah, this is mostly what we had for the use case. Again, the this part we were not able to integrate in this one demo where we can have the smart contracts and all of the CDS can just go to the yeah to the smart to the blockchain with the service level agreements and everything like that. But we already do have the smart contracts written in this repo, and yeah, we also have like a step-by-step procedure. However, you can set this up. It's already Dockerized, so it's just like a one-click thing. And yeah, and right now we are running this local node of Hyperledger Indy for us, where all of these dates are getting stored. And again, the Ethereum testnet, which I already mentioned. But yeah, I think this would be for the demo part. I guess Vipin, so you can take over.
Yeah. So thanks, Dinkar. Let me share my screen for you, please. Yeah.
Yeah.
Alexander, you want to ask some questions? Yeah, here it is.
Stop share.
Okay. So meanwhile, I also want to share that we have a solution brief on this project, and I hope my screen is visible, right? Yes.
Yes, it is.
Okay. So we have released this solution brief. Again, this is the first step only, right? So the idea here is to work with different telecom operators and try to bring some consortium, some use cases. That's what we started. And you can read whole solution brief on it, and how you can integrate these DIDs with different use cases. And of course, we use Hyperledger Redis and Indy, which is like de facto for DIDs nowadays. And which and if let's say if you think that okay, this is a particular use case we can add into this, we can do this. And again, code is open, and then you can create issues, and you can join us on Hyperledger Labs or in our telecom sec calls as well. And again, this is like a very so we have a limited time for this internship. So we are also trying to expand this because DIDs, because this is related to identities and how we can save these identities by using post-quantum encryptions or other security methods. That what we are planning. And of course, you can use this solution brief as a standard or a standard point or where you can start working on things. So you can find these papers, and if you have some suggestions, you can send us on Hyperledger Labs or create an issue on it, or even you can join SIG calls. Thank you so much. So we are open to questions.
Yeah,
Yeah,
and
hi.
sorry for the yeah.
Yeah, carry on. Yeah, sorry.
Yeah, sorry, just for the question Mr. Alexander asked. Yeah, so the extension was like MetaMask, and you just use it to sign the transactions. So let's say we are just telling the blockchain that we want to have this IMEI number, right? Want to register this IMEI number with this TID and stuff. So you need to also sign this with your keys, so that we always have like this reference point who was the one who initiated this transaction. So it's mostly for the transparency sake and also for communicating with the blockchain back and forth.
Hi, this is Ram Kumar. I just want to appreciate Vipin and Dinakar for doing this project. It looks very interesting. So I have a couple of questions. So first one is, if you put it in the public blockchain, for example, the CDR is a very good use case, but is the public blockchain scalable for the number of records that going to be generated in a network? It's because lot of CDR record will be generated, but I'm not sure about the current transactions per second allowed in Ethereum. So that's my
I
first
agree.
question. Yeah.
Yes.
So
So Ram,
yeah.
I agree with this because L1 solutions are not that much scalable, right? So that's why we can use L2 solution for these blockchains, where we can get higher throughput and higher TPS. Again, and again, this is a particular use case, right? So that's what the idea here is to use public blockchain, so that of course there's a issue of scalability all the time. So that's what in the second phase we also planned that how we can integrate BSU as well as with the Ethereum, so that whatever we want, I mean, can we decrease this throughput and TPS, in terms of using BSU and integration with the Ethereum as well. So yeah, of course, TPS is a little bit issue in the L1 layer, but I think L2 can scale it better.
Okay.
Yeah, and
And
sorry, just to add, I think we can also look at different blockchains like Solana. I think it is so you write smart contracts, invest in there, so you also get this benefit of memory security and stuff. And I think the transaction rate for Solana is very, very nice. I think they claim that it's more than Visa, so that's another point. And yeah, and then it's like very dependent on the telecom operators too. So if they want, they can always go with this private blockchains like Hyperledger Fabric. If it's like very particular to the use case and what they have in mind. So yeah, I think yeah, something like that.
yeah, my second question is, what about feature phone? I have seen this DID for, I mean, for a lot of applications that in European Union also they are using for EIDAS and all these solutions. So I'm wondering, because I'm not sure about in the wallet how it will be stored. So in the feature phone, is it possible to use the same decentralized identity for a feature phone? That I mean, a phone where you don't have a wallet support or a option to store the DID.
Oh, good, good question. Means I never thought of it, but this is same. Like for example, I think you can use your UPI or stuff in the feature phone as well, right?
Yeah,
So
yeah.
maybe some lighter version or something which you can use
But
it, but
my question is, does it require? I mean, does the phone requires to have a wallet support, or 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 in feature phone also, is there any way that we can do it?
Mhm.
Because hypothetically, if the government wants to do such solutions, we can't. If you're not able to cover the feature phone, then I mean, it doesn't have a parity. So I'm wondering if it because I'm not sure. Do you actually need that secure hardware, TPM, or those kind of things to be present? Because in all our modern phones have all the wallets, right? Uh, uh, so I'm wondering, is there any special wallet required, or you just need an application to store the DIDs?
Very interesting question. So okay, uh, in terms of storing something, let's say whether it's feature phone or smartphone, in my opinion, what we can have is, let's say in feature phone, or we have a SIM, right? In SIM also we have keys, some kind of keys, whatever, right? So in that context means, whether it's in SIM or something, we can add these numbers, right? Whether it's key terms or DID. But feature phone I never thought of, but it's a good use case that we can look better. But not much idea about feature phone as well. So
Even I was thinking the same. I asked many people. I had this idea how to do it for a feature phone. But yeah, and then one more thing I want to share. I'll share it offline in the mail. So there recently, ATIS, the American Telecommunication Association, right? They released a document of a solution, this DID solution for a SIM swap use case. So what happened in US is these hackers bribed the telecom operators employees for $2,000, $3,000, and they were performed SIM swap operation. So they proposed a solution using DID. So before performing a SIM swap, you can verify your DID, then perform again.
So I
So
think
that
we have
use case
added,
also we can
yeah,
add.
we consider this use case. So I think that's what we have added as well, that this customer should talk to DID network and before, even for the once you change the operator, right? At that point also you can use these DIDs, right? So yes, there are use cases, right? There are many use cases. That's what we have tested with 4 and 5. That's how we can write smart contracts, how we can integrate things from DID to the different blockchain networks, even, right? So that's the first starting point. That's what we have achieved in this POC. But again, we want to expand it to the other use cases as well. That's what I was discussing with in the SIG calls, that how we can integrate even post-quantum encryptions in the DID, so that in the future it is more secure, right? And same way, like you mentioned, feature phone. Of course, we will discuss this, and then we will read some stuff, and also you mentioned that for the SIM swap or other use cases as well, right? So there are many use cases around this DID and telcos, and even when I was in MWC, and there was a lot of talks on this particular topic, that how you can integrate DID and telco stuff, especially related to OTPs. So yeah, there is a scope for sure. That's why we released this solution brief, and so that we can take some feedbacks and then update our code as well. And that's why we released in Hyperledger Labs, so that any telecom operator can come and join us, or they can give us feedbacks, or we can code around the same.
I think you've done a very, very wonderful job. Thank you. Thanks a lot. Thank you.
Thank you. So do we have any more questions? If not, I think David, you want to add?
Sure. Yeah. Thanks everyone for joining. Thank you, Vipin and Dinkar. And yeah, I'll post this recording to YouTube, and I'll post a link to the Telecom SIG list. And then if you have your presentation to share, you can send it to me as well, and I'll add it to the YouTube description as well, so people can find it there.
Sure. So I will upload in the SIG meetings, and then you can give this link.
All right. Perfect. Great. Well, thanks everyone for joining.